సార్ వీడియో అవుతుందా? హలో హలో సార్, హలో
ఇందాలాగా హిస్టరీ క్రియేట్ చేసిండు అతను కానీ వస్తుండే హిస్టరీ క్రియేట్ చేసింది
సార్ ఒక్క నిమిషం సార్.
కానీ మధ్యలో ఛార్జింగ్
సరే
ఛార్జ్ కూడా పెట్టండి. పవర్ పాయింట్ ఇక్కడ ఓపెన్ చేసి మినిమైజ్ చేయడం,
మినిమైజ్ చేసి ల్యాప్టాప్
ఛార్జ్ పెట్టండి.
ఛార్జింగ్ అయ్యింది
పెట్టండి.
ఛార్జింగ్ పెట్టండి సార్.
ఏది జస్ట్ మీ ల్యాప్టాప్
జస్ట్
అందులో పవర్
మీ ల్యాప్టాప్.
సార్ గుడ్ మార్నింగ్ అండి. ఓకేనా? ఒక్క నిమిషం. పెన్ డ్రైవ్ కూడా పెట్టాలి. అదే డేట్ ఉంటుంది, కాపీ చేసి గేట్ ఉంది, డేట్ ఉంటుంది. ఆ ఫోల్డర్ అంతా కాపీ చేసి డెస్క్టాప్ మీద గేట్ అని డేట్ ఉంటుంది కదా. ఈరోజు ఎంతమంది ఉన్నారు లైన్ లో? వెళ్ళిపోయారు కంపెనీస్. ఓకే 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 ఓకే. Good morning, dear student friends. Today there is some network problem. Internet wires are connected here due to rain. Today we are going to discuss with the kinematics of particle, point mass and rigid body. The last 5 classes we have concentrated mainly on the statics part. Today we are going to concentrate on the dynamics part. In that, you know very well, the dynamics is classified into kinematics and kinetics. Sorry for delay for the today class. Today we are mainly concentrate on kinematics. Tomorrow we will discuss the other parts, kinetics and other things. Here if you can see the syllabus from the mechanical and civil, this is what is there. These all we have covered. Now today we are going to cover kinematics of point mass or rigid body or number of particles. Here also kinematics and dynamics. Today we are concentrating only the kinematics of particle of a rigid body. See, before discussing the dynamics, let us see the little bit introduction. What are the learning outcomes we are going to get today? Represent or express kinematics of a particle or rigid body and differentiate between in kinematics generally classified into kinetics and kinematics, and recognize and apply the concept of different dynamic principles in kinematic analysis and kinetic analysis. Here the basic thing is Newton's laws are we are using for dynamics. As for dynamics is concerned, momentum, impulse, work energy, D'Alembert's principle, etc. You will get an exposure to solve the different problems by using these principles. calculate kinematic quantities like different types of motions like translation, rotation, plane motion of a particle and rigid body. See, as a student, once you clear the concept, you can apply any types of motion, either a particle or a system or a number of rigid body or number of particles. The same concept holds good. You have to update your knowledge of this course because it will need in the other subjects. In the other subject, this particular these topics will be useful. Okay, so this is how we will try to discuss the learning outcome what we are going to get from this particular topic. So let us first see what is the difference between a particle and a rigid body. Here the size and shape not important. Indirectly we don't consider any dimension. That's what the particle. If you take number of particles connected like that, we'll get the required shape. Size and shape has to be considered. That we are calling as a rigid body. The size and shape has to be considered, for example, because length between point A and point B may affect the kinematic solution. That means that the length is not changing when we are calling it a rigid body. For a particle, size and shape is not important as it is treated as a point. That's why here in a rigid body, shape is important, but we are considering that is not changing. Rigid implies that the body cannot be deformed. Or in other words, if you take 2 points on a body after application of load, before application of load, if you measure the distance, if the distance is not changing, that type of body we are calling as a rigid body. This is how generally we will consider. Okay. So now let us consider what are the different shapes generally we come across rigid body. Rigid body can be particle is like a dot we will represent. It is no dimensions or a cross. But rigid body can be represented as a block or a disc or a wheel or bar or a member, etc. Like that you take any beams, anything, flywheels, either a motion of a single particle or a rigid body. We can consider the same analogy. Or number of particles is a rigid body, nothing but. So now that's what, if you can see here, the particle, many particles combined will get a rigid body. These are the three ways generally will consider. But this and this one and all indirectly same. That's why a particle and rigid body. We can use here a vector approach or a scalar approach. Both the things we can do in the analysis. Either vector approach or scalar approach for any external system in a macroscopic or a microscopic scale. Here if you can see, the system can be a fixed system or a moving system. Some of the force is equal to 0 for a fixed system and some of the force may be greater than or less than what when the system is in a indirectly dynamic system. Pure study of motion or study of both motion and its cause. Here pure study of motion's cause and here motion and cause separately, pure study of motion. Like this we can consider for a moving system. Whereas fixed system, motion's cause only we will consider. Then as far as the particle is concerned, we will consider the statics of a particle. This is statics and this is dynamics. In the dynamics, we will consider kinematics of a particle or kinetics. That is, dynamics is generally classified into kinematics and kinetics. Whereas statistical mechanics is the kinetics of many particles like this. This is indirectly rigid body that is represented as again kinetics of a rigid body or kinematics of a rigid body. Again dynamics and statics. This is how generally these two are the static analysis. These two are the dynamic kinematic analysis, and these three are the kinetic analysis. Okay. See, this is how generally we can come across the different types of combinations of engineering mechanics problems. Once again, we can solve a scalar approach the problem, we can solve in a vector approach for any external system. We can do in macroscopic level, microscopic level, nano level, or any level we can consider. It can be fixed system like statics or dynamic system, moving system. Here, consider statics of particle or dynamics of a particle, statics of rigid body or dynamics of rigid body. These are the combinations what generally we consider when we are considering the problem of a moving system which is under dynamics. This is what indirectly a mechanics with the dynamics of a particle or dynamics of a rigid body classify into two types. One is statics and another is dynamics. In dynamics again it is classified into kinematics and kinematics. Kinematics is study of the space-time relationship. The space means again the degree of freedom. If it is a 1 degree of freedom, let us x displacement. Translation. If it is a rotation, theta about the axis. Either a translation or a rotation. Like a piston moving forward, backward. It is 1 degree of freedom. Like a crankshaft rotation. It is 1 degree of freedom. Like that, the kinematics is the study between the space-time relationship. Always we will try to consider the coordinate system, like a rectangular coordinate system, polar, cylindrical, or spherical, etc. In that case, generally what we will consider is those spatial quantities represented with x with time t, y with time t, z with time t. Okay. That is what is called the three translations and three rotations. X translation, Y translation, Z translation, X rotation, Y rotation, Z rotation. It is classified as kinetics and kinematics, statics and dynamics. In the dynamics, it is kinetics and kinematics. Space means, suppose if it is a two-dimensional problem, x, y and rotation theta. What is the space-time relation? X with t, dx by dt, velocity, dy by dt, velocity in y direction. Then velocity differentiate with t, dv by dt, acceleration. dvx by dt, velocity in x direction, the acceleration in x direction. dvy by dt, acceleration in y direction. Again differentiate acceleration with respect to time. Jerk. See, like that you go on up to any level. That is what is called the kinematics. That means what we can conclude is kinematics is indirectly representation of space and time relationship. Represent with the space and time. Kinetics is the not only the space-time relationship, you have to consider what is the cause of motion, that is the force as well as mass on the body. It is a combination of all, that's what we are calling the kinematics, like Newton's laws, D'Alembert's principle, work energy, momentum impulse. These all concepts we will consider under the kinetics. Kinematics we will consider only space-time relationship, like velocities, acceleration, displacement, jerks, etc. Only kinematic quantities. No force, no mass. Whereas in static problem, only consider the force. We have not considered any like cause of motion, acceleration. In kinematics, only what is the motion only will consider separately, and force and masses we will consider in kinetics. Now let us see how we define a dynamics. Dynamics is concerned with the study of motion, any type of motion. Different types of motions we'll discuss. And system can be observed for any external inputs like forced vibrations, free vibration or a forced vibration, like model analysis, mode shapes and natural frequencies we can get for any system. Harmonic analysis, transient analysis, random analysis. See, it is concerned with the study of motion. System can be observed from model, harmonic, transient. Harmonic means sinusoidal, sine input, cosine input. Transient is a sudden input or a random analysis. It is a macroscopic or microscopic. Kinematics or kinetics. Any scale or even nano level. This is how generally we will consider the dynamics. Now let us see what type of motion generally in kinematics. Types of rigid body, either it is a translation or a rotation or a plane motion, a combination of both. I already explained earlier, if you take IC engine mechanism for mechanical engineering student or even civil engineering student, you are also using number of times piston, cylinder and crankshaft to lift a body or heavy weights, etc. In that case, the piston is a translation, crankshaft is a rotation, connecting rod is a plane motion. See, all three is included in one system only. So like that, we have a different types of motions in, suppose the train is moving from one station to another station. The train starts gradually increasing the velocity. That is, when you go on increasing the velocity, acceleration is change in velocity time. Then velocity constant, acceleration 0. Then once it is observed the next station, it has to decrease the velocity. It is again acceleration, but it is a retardation. See, like that, in a sequence of operation, we will get all types of condition. Acceleration may be 0, acceleration may be positive, acceleration may be negative, or sometimes acceleration is also variable. See, this is how generally we consider translations and rotations, or a combination of both, like a connecting rod. So this is an example of when a body, rigid body consists of AB, distance is always same. If you can apply a force, it is A is moving to A dash, B is moving to B dash. It is a linear displacement. Whether you can measure here or here, it is same. That is what is the meaning of linear. It is a rectilinear translation. This is generally one case of idealization problem. So now here, the types of rigid body motions are, this I already explained, this part. Rigid body motions are translation, rotation about fixed axis, general plane motion, combination of translation and rotation. Based on that, see, this is the degree of freedom translation is 1, like piston. Rotation about fixed axis, degree of freedom is also 1. It is a translation and it is a rotation. A plane motion, it is having a 2 translations and 1 rotation. Motion about a fixed point. Okay, and general motion. The translation motion is a rectilinear translation or a curvilinear translation. Again, this translation is defined as if the distance this and this are same, it is a rectilinear. If it is different, it is a curvilinear translation. Okay. So this is how generally we'll consider. That's what I explained here. Kinematically speaking, the translation orientation of AB constant. Okay. AB can be distance between any point is constant. This is a translation. Here also any point distance is constant, but is forming as a curve. Okay. In a combination is called this plus this. It is a plane. Combination is called the plane motion. Now another degree of freedom is the rotation. This is the translation. Translation can be pure translation and rotation and the curvilinear translation. Like projectiles, this is a rectilinear translation, 1 degree of freedom. It is a curvilinear, like projectiles. When you throw a ball, it forms a path. That is what is the projectile path, curvilinear path. In that case, X translation, Y translation. That's why 2 degree of freedom. Pure translation, that is the rectilinear translation is having 1 degree of freedom. Curvilinear translation is having 2 degree of freedom. X translation and Y translation at any point, or sometimes normal and normal and tangential. Either you can consider a combination of XY or you can consider the combination of normal and tangent. Sometimes rotation. Rotation about a particular axis. That is how, or a combination of all this translation. Rectilinear translation and rotation. That means rectilinear 1 degree of freedom, rotation another day, total 2 degree of freedom. A combination of curvilinear motion and rotation. Curvilinear consists of 1 translation, 1 rotation and rotation, 3 degree of freedom. So this is how generally we will consider translation, rotation, plane motion. That is a combination of translation as well as the rotation. The rotation of a rigid body described by its angular motion. All lines of a rigid body in its plane motion. Let us consider plane, how the body is rotating. Here if you can see this is the tangential velocity r omega, tangential acceleration r alpha. This is the normal acceleration r omega square. There is no normal velocity, acceleration only. At is equal to r alpha and a normal is equal to r omega square. The tangential velocity is r into the vector, that is angular rotation. It is in a scalar notation. Sometimes you can use a vector notation. This is a scalar notation. V is equal to r omega. Normal acceleration is equal to r omega square or v square by r. By substituting omega is equal to v by r. This expression. Omega is equal to v by r. Tangential is r alpha. Or a vector notation, cross product. V is equal to omega cross r. A normal acceleration is r omega square in scalar. In the vector it can be represented like this. This is how scalar and vector can be represented. And one more important point is, when a system is having a rotation for acceleration constant, in that case, that is increasing velocity linearly. If a velocity is increasing linearly, acceleration is a constant. So in that case, if alpha is constant, in that case, theory relations are valid. That is omega is equal to omega naught plus alpha t. Omega square is equal to omega naught square plus 2 alpha theta minus theta naught. Theta is equal to theta naught plus omega t plus half alpha lt square. Okay. This is how generally we'll consider for these 3 equations are valid only when the acceleration is constant. If the acceleration is variable, these equations are not valid. That is one thing we have to keep in mind. So this is how the rotation of a body kinematic analysis can be represented for acceleration constant, these three equations are valid. We can consider the problem in scalar notation, or we can consider the problem in vector notation. So these are, if you can see the first four figures, these are the best example for the rotational, that is a rectilinear translation, curvilinear translation, rotation and plane motion. Plane motion is a two-dimensional. Say that is the here either this plus this or this plus this. If you take this plus this, 1 plus 1, one translation, one rotation. If you take this plus this, it is two translations and it is one rotation. Okay, total 3 degree of freedom. See, that is how, if you can take here, in a, this is having 1 degree of freedom crankshaft, piston is having a translation 1 degree of freedom. Because this end is rotation and this end is translation, definitely it is a combination of translation and rotation. It is a plane motion. So here, this is omega f plus omega naught plus is there here. Plus alpha t, same previously given. Theta is equal to average initial and final angular velocity divided by 2 into t. Theta is equal to omega 2. And this is what is theta is equal to omega naught plus half alpha t square. And omega f v square minus v square, like that. F square minus w square is equal to 2 alpha theta. So these are the expressions we'll consider. This is already explained. Sometimes comparison between the, see here, angular motion and linear motion. V is equal to dr by dt, acceleration is equal to dv by dt. Jerk is equal to dA by dt. Here s is equal to r theta. You differentiate ds by dt r into d theta by dt, like that. If you can simplify the problem, you'll get omega d theta by dt and alpha d omega by dt. Angular motion. If it is a linear motion, it is v is equal to dr translation, whether angular or linear. This is the equation. Difference between a translation and rotation. This is s is equal to s naught plus v naught t plus half a t square. This you are already familiar with an intermediate. V is equal to v naught plus a t. V square minus u square is equal to 2a s minus s. Whereas here theta, same relation in terms of theta, linear angular velocity and angular acceleration. Here linear velocity, linear acceleration and time t. Okay. See, this is how generally we will consider the problem. If it is in a vector notation, say here, this is the what we are called the scalar notation, and this is the vector notation. VA is equal to VB plus omega r. That is the, and the acceleration is also linear acceleration plus angular acceleration, normal component and tangential component, r alpha into r omega square, r alpha plus or minus r omega square. Omega cross r is always a cross product of ijk is the vectors. Then what are the elements in the each row of the matrices? You have to consider. See, this is how generally we'll consider the relation between the translation and the rotation degree of freedom. Now this we already done earlier. All mechanics problems are deals with 3 laws of motions: Newton's first law, Newton's second law, and Newton's third law. But why I want to this mention it? Why I am mentioning this particular point is this law, first law, also called as the law of inertia. What is inertia is defined here. Okay, every body in the state of rest or maybe uniform motion unless there is no external or unbalanced force. That is, when the system is at rest or when the system is moving with constant velocity, we can solve this type of problem. This is purely a static principle, first law. Second law, this is the second law. rate of change of momentum indirectly, or second law form the basis for analysis of accelerated motion, which is dynamic motion. That is F is equal to ma. What is the force acting on a system? What is the mass of the system, and what is the motion like acceleration, accelerated motion? And force and acceleration must be proportional, and it should be in the same direction. So that is how we will consider in the second law. Second law purely applicable for dynamics. First law purely applicable for statics. Then third law is, for every action there is an equal and opposite reaction. The analysis shown in the figure for A and B particle. One is force A on B and another is force B on A, action and reaction. Now let us consider kinematics. In statics, it was considered that the rigid bodies are rest. In dynamics, we consider it is in a motion, like translation, rotation, or a plane motion. Dynamics is already mentioned, we have broadly divided into two branches, that is the kinematics and kinetics. Kinematic is a relation between the type of motion, that is the space-time relationship. What type of kind of motion, whether it is simple harmonic motion or like that also we can define in kinetics. Because wave force is also a major parameter in that. Now let us consider in kinematic, we are talking about displacement, we'll talk about velocity, we'll talk about acceleration, we'll talk about the other parameters in the system. See, that's why if you see the figure, a particle is moving from the origin x distance from a fixed point A. This displacement, when you consider as a function of time t, with respect to time it is changing. See, that is what is called x is equal to ft. That is one equation. The second equation is x is equal to c plus bt. And two more equations if you want to consider, if you note down, x is equal to half gt square, or x is equal to x naught e power I omega t. Like that you can consider any type of function. Some function of t, the general displacement. Please write the three equations. X is equal to c plus bt and x is equal to half gt square. X1 is equal to c plus bt, x2 is equal to half bt square or half gt square, and x is equal to x naught e power I omega t. See, like that we can write the three equations to solve the problems. See, now see what type of motions we are getting by considering the three analyses. When x is equal to c plus bt, if we differentiate with respect to time t, we will get the b, constant velocity. When a displacement is linear, obviously one order will reduce. Velocity is a constant. Initial velocity. Then initially 0 and find that is what is s is equal to u plus a, v plus u. V is equal to u plus at. Similar expression. If you can consider, here x is equal to c plus bt. C and b are the constants. Now the second equation, half gt square, if you can. It is something like a x versus time is a parabolic because quadratic nature, half gt square. Now differentiate with respect to time t. We will get gt. That is a linear. That means the quadratic is reduced into linear in terms of velocities. Similarly, you get the acceleration. When it is linear acceleration, dv by dt will get the constant. This is how, that means what I can say is, When it is a displacement is linear, velocity is constant, acceleration is 0. That is a uniform motion. When the displacement is object is square, velocity is linear, acceleration is constant. See, that is how depend upon the situation we are going to get from time to time. In any case, whereas x is equal to x naught e power omega t, if you differentiate, then we'll get omega into e power I omega t. See, that exponential function is continuously changing. It may be positive, it may be negative, then go to the j, that is what is the acceleration. Once again, e power I omega t into omega differentiate. Omega is a constant. You further differentiate, you will get omega square. So this is how, depend upon the nature of the displacement, you will get the corresponding velocities, corresponding acceleration. If acceleration is linear, like c plus bt, acceleration should be, you will get a constant. But whatever may be the reason, if acceleration is 0, we will get the acceleration 0, acceleration constant, acceleration variable. The 3 cases we will get. This is what I said of gt square, where dx by dt, gt 2 will be cancelled. Velocity is linear. When displacement is quadratic, velocity is linear. Why? Because we are differentiating with respect to time. Once again, differentiate with respect to time, we will get g. That is the constant acceleration. That is quadratic to linear, linear to constant. If you want to jerk, you will get 0. Like that, we have to consider the type of motion. Okay. This is regarding the pure translation part. Now let us see the one problem. This is the problem we are going to solve in the kinematic analysis. The rectilinear motion of a particle is defined by the displacement and time equation, that is x is equal to, this is the equation, x is equal to initial displacement, velocity in time of a t square. Find the displacement and velocity at time t is equal to 2 seconds. See, these are the data which is given initially. The equation of motion is this. Then find out velocities dx by dt. Differentiate with respect to time t. Now see here, displacement versus time t, that is a quadratic nature. Velocity versus time t is a linear. Acceleration versus time t is constant for object square. If it is an exponential function, all are exponential, but one time is positive, one time negative. That's how we will get represent the different types of the motions. Now let us solve the small problem. Note down. A bullet, this is given in one of the, so many times in the examinations, competitive examinations. A bullet leaves the muzzle of the gun with velocity is 750 meters per second. Starts from rest, it will leaves at, that is the initial and final velocities. Initial 0, final velocity 750 meters per second. Assuming constant, these what are the, that means input, what input is given, we have to try to get extract. Initial velocity is given, final velocity. Assuming constant acceleration from the reach of muzzle, find time to occupy by the bullet in traveling through the gun barrel, which is 750 mm long. That is S is given as the 750 mm, convert into meters. So you will get the S is equal to this much. Now if you can see the expression V square minus U square 2S then simplify, then similarly you'll get the other part. Then let us consider the second problem. Note down. A stone is dropped into a well. A stone is dropped into a well and falls vertically with constant acceleration. S is equal to 9 point, or G is equal to constant acceleration. Let us consider G 9.81 meters per second square. A stone is dropped into a well and falls vertically with constant acceleration S is equal to 9.81 meter per second square. The sound of impact of stone in the bottom of well is reached after 6.5 seconds. The sound of impact of stone in the bottom of well is reached to be 6.5 seconds. If velocity of sound is 336 meters per second, if velocity of sound is 336 meters per second, how deep is the well? How deep is the well? Here if you can read the problem, what is the input data given? The constant acceleration, that means you can use S is equal to ut plus, because it is a translation problem. S is equal to ut plus half h square, or v square minus u square is equal to 2s, or v is equal to u plus 8. You can use those relations, depend upon the data. Here what else is given? The sound of impact of stone in the bottom of the wall is reached by within 6.5 seconds. But that means when you are dropping a stone, it is reaching bottom of the wall. That is the distance is S. Time taken during that S1 is one thing. Similarly, the return, the distance is same, but time is T2. The sound which will receive from your air. See, that's why here S is equal to ut plus half h square. We use it given based on given data 2 times T1 plus T2. But when the stone is dropping, initial velocity is 0. Now S is equal to ut plus half h square. Initial velocity is 0, that's why ut is 0. And h, that is what is the S. By substituting this, we can get time T1, this is T1, because constant accelerated motion. If you can simplify further, in substituting the equation, we will get a quadratic nature in this, because this is one equation, T1 plus T2. Now T is the expression, T1 is already we got in terms of 2s by g. Now substitute these all. In S is equal to Vt, this is the, when the sound travels from bottom to the, here Vt2, okay. Now S is equal to same distance from bottom to top, S is equal, see, but one case S1, the S1 or S2 both are same, but during going from relieving the a stone, that is a constant acceleration, uniform, that is what the equation. Whereas here, S is equal to Vt2. Now, by considering these two equations, this S and this S are same. This S are same. Now, if you can equate the equations, it is a quadratic. If you can equate, we'll get this is the equation. Finally, if you can simplify, we'll get 6. Okay, so like that we can try to solve the number of problems. So this is what is called the translation part. I have solved 2 problems. Like that you can do any number of problems. But see here in any of these problems, we are not consider the mass of the body, we have not considered the forces. Only the kinematic quantities, the relation between the space and time. There is displacements, velocities and accelerations. Now let us consider curvilinear translation. The best example is a projectile motion. If I can throw on chalk piece, it will follow some path. The path you can consider assumed as a quadratic second order equation. It is the best example of projectile motion. To define the particle here at a rigid body, we need coordinates. That's what when distance is s, the incremental distance is pp1 ds. At this particular point, it is at that level. The stress is px, py, and px. Or for any particular point P, the incremental value take delta x and delta y, I psi 1, a displacement is delta s. Now consider here because it is a curvilinear translation, the only comparison between rectilinear translation and curvilinear translation is we have x translation and we have y translation, 2 degree of freedoms. That's why x is equal to f1t, y is equal to f2t. You have to consider 2 functions as a displacement. You can start. That means R you can consider y is function of x and path along the path. Yes. Here s is function of time t and y is function of x. This is function of x. This only consists of function of t. Okay. Where y is a function of x is represented, the equation is along the path y. It is having 2 degree of freedom, 2 translation, x and y direction. See, then the velocity is along this path, the velocity is ds by dt. That you can resolve the x component and y component, dx by dt and dy by dt. See, that is what the average velocity in x direction is dx by dt. The average velocity in y direction is dv by dt. See, this is what is the kinematics. Then the linear velocities vx dot square, vy dot square, where cos component is, if you can draw a triangle x and y, opposite side by, that is a x cos theta, sin theta, cos theta component, x component opposite side by the diagonal, y component by the diagonal. This is how we will consider the components. Then acceleration, further differentiate. The acceleration is equal to dx dot by dt, dy by dot t. Now let us take, this can be represented easily by simple harmonic motion. X is equal to r cos omega t, y is equal to r sin omega t. Particular path. Here this is r, this end, this is omega t. X is equal to r cos omega t, y is equal to r sin omega t. And x square plus y square, this square plus this square, r square cos omega t, r square sin omega t. You take r square common factor, cos square omega t, sin square omega t is 1. That is the basic expression for simple harmonic motion. In this case, x dot is minus r omega sin omega t, y dot is r omega cos omega t. We differentiate this displacement function with respect to time t. then average, that is linear. Rotation and translation can be combined like this. Theta is equal to square root of x square plus 1. The velocity, resultant velocity, not theta, resultant velocity. Here there is no rotation, translation. The resultant velocity is x component square plus y component square. See, that is how once we know the x dot, now go to the x double dot. This one. Because omega is the variable, sin omega t, omega is variable. Y is also same. Okay, this you differentiate r omega square. So this is what is the normal acceleration, normal velocities, r omega square. Similarly, you will get the, this is what is the, and also we can rectilinear piston is moving along the path. It is a rectilinear motion. The curvilinear is when it is taking certain path. Okay, it is a curvilinear motion. X double dot and y double dot we can get. Now let us consider the rotation. Rotation of a rigid body. Angular motion. The rotation is a change of angular displacement with respect to time. In other words, d theta by dt, omega. Instead of linear velocity, now it is angular velocity. Omega is equal to d theta by dt. Similarly, alpha is equal to d omega by dt. That is the first equation. You differentiate with respect to time, you will get d square theta by dt square. This also can be represented as, alpha can be modified as d omega by dt, that is d omega by d theta by dt. D theta by dt is omega, d omega by d theta. Like this also we can modify. But the rotation kinematic quantities are generally will consider when the body is in a rotation. That is alpha is equal to omega into d omega by d theta. Generally we will consider. Now relation between the angular motion and linear motion. Like normal acceleration, tangential acceleration. We can consider sometimes. When it is a tangential to the path, when it is coming to the acceleration, we have a normal acceleration, we have a tangential acceleration. Now let us start with the displacement along the path s is equal to r theta. S is equal to r into theta. That's what we have written here, s is equal to r theta. The tangential velocity is ds by dt. This s is substituted as r theta. R is constant. This r is constant. It is not variable. You take outside. The tangential acceleration is r is equal to d theta by dt. Because dv by dt. Acceleration is equal to dv by dt, tangential. V can substitute, further simplified. V is equal to r into d theta by dt. That r is constant, d square theta by dt square. So this is how we will consider the tangential acceleration, the tangential acceleration dv by dt r omega square. That's what r omega square. This is the tangential r alpha d square theta by dt square, and normal is v square by r, the radial acceleration. This is the tangential r alpha r omega. D theta by dt is omega. Okay, d square by theta by dt square is acceleration. R alpha, normal acceleration is r omega square, v square by r. So that's why the tangential and normal can be represented as sometimes when you are solving a problem of a rotation. Sometimes the relation between the speed number of rotations and angular velocity for one cycle 2 pi n by 60 omega is equal to, this is one conversion we are using wherever is required. So this is what is the introduction of translation, rotation. In a translation we have considered the curvilinear translation, rectilinear translation. So now let us come to some more concepts. Now the plane motion. Plane kinematics of a rigid body is it is having a translation as well as the rotation. That is what is called it is in a single plane, not in a space. Space is different. But as far as your syllabus, we will consider, as far dynamics is concerned, always we are considering in plane only, single plane. See, this is what I already explained. In a plane motion, we have a translation, we have a rotation. Rocket is a translation. Linkage, this is what is the rotation. Rotation, this is the translation, curvilinear translation. This is the rotation. Either this plus this or this plus this. We can get the 3 degree of freedom. And this is the combination of this is the combination of this plus this or this plus this. If you are considering this plus this is one translation, one rotation. If you are considering this plus this is two translations, x and y, and this one. Rotation. This also we discussed already. All expressions, etc. It is in a, just now I derived normal acceleration or tangential acceleration. Okay, normal, same thing. Omega is equal to theta dot d theta by dt. Here d square theta by dt alpha. So that's why normal acceleration is r omega square or v square by r. Tangential acceleration is r alpha. Linear, the tangential velocity is only one component, not like a normal is when you are making r dot, it is 0, v is equal to v dot r theta dot r omega. There is no normal velocity, only the tangential velocity, that is equal to r omega. This is the vector notation. Same equation, if you can represent in a vector notation, this is what the equation. You can solve the problems in a scalar, or you can solve the problem through vector. Velocity omega cross r is positive, r cross omega is the negative velocity. Similarly, acceleration omega cross r, omega dot cross r, that can be in vector. Further simplified, this is the expression what we get. Now plane motion is combination of both. Okay, both the translation and rotation. This is what is the plane motion. V plus A with respect to B, because we are considering translation part and we are considering rotational part, like r omega. Okay, the total velocity is translation and rotation. This is what C. This distance and this distance are different. So that's why what we are doing, parallelly we are moving in x coordinate like this. Then at the joint there is a translation. This is what the different other motions, rotation about A or rotation about B, it consists of translation and rotation. Okay. This is a plane motion. The V, A with respect to B or B with respect to A, we call it plus R omega cross R or R cross omega. That is plus value or a minus value we can consider. Same thing. Notation or a scalar notation. That's very, very important. That means a plane motion consists of translation part as well as rotation. Rotation is this component. It is these are the expressions generally we come across. Belt motion is in terms of velocities. Any point is required. Velocity of A is equal to velocity of O plus velocity of O with respect to A. This here this particular block is moving with velocity V naught with a radius of at a point A on the wheel considered that radius is 200 mm. Okay. The directional relative velocity is V is equal to R omega. That means so A is moving away from the center with O. It is along the line it is translation as well as rotation. O with respect to A, moving along translation. This is and rotation also. So that's what we have substituted here. Omega is equal to V by R. R is 0.3 total. This is constant, but this point is variable. Okay. V R omega A with respect to it is a R is 0.2 into omega is constant. The vector sum is, this is the vector sum equation. V velocity of V square is equal to here 3 square plus 2 square minus the plus or minus the next component. This is how the velocity square will get. Velocity is meter per second only, but the square unit we are considering. Then this point, any other point, we can consider O is along the radial line or any other point. From the geometry, you find out this particular distance. This is AC by V with respect to is R omega, that is R is AC here. This one. And you simplify here and find out the velocities. This is what is called. Now, this is another important concept. The instantaneous center method also can be used. Relative velocity method and instantaneous center method. Two methods can be used to solve the problem in the plane motion. This instantaneous center method we'll try to discuss in the next class. But what we have considered today, with this we'll stop. Once again, we can recollect what are the motions we have considered today. Only the kinematic and the introduction of dynamics are given. What are the different situations of dynamics and different principles like Newton's laws, etc. What principle we are going to use? Newton's laws, D'Alembert's principle, work energy, momentum impulse. And those all analysis we have not considered, only we have considered the kinematic analysis today. In the kinematic analysis of translation, in the translation, rectilinear translation, curvilinear translation, and rotation, and plane motion. In the plane motion, we have two methods. One is the relative velocity method, second one is the instantaneous center method. we have considered relative velocity method. Instantaneous center method we will consider in the tomorrow class. Okay, today, sorry for delay starting network problems. And this part, whatever is not covered, we will try to cover in the tomorrow class. Tomorrow we will start with the kinetics part. Today we are considering only kinematics. In the instantaneous center method is little bit left. That we will see then the next class. But tomorrow we will basically more concentrating on the kinetics of a particle. Once again, if you have any queries, please send to the Google Forms. Then we will clarify the doubts. But here in the dynamics, the problems are very easy, but here you have to understand the small concepts. What type of motion, what is the type of acceleration, is it zero or a constant or a variable? Accordingly, we are going to use the kinematic relations. That is one thing you have to be careful about that. So with this, we will stop today class. Almost more than 45 minutes. We have a network problem starting. But don't worry, that part we will cover in the next another 6 classes we are engaging. 3 to 4 classes we will cover another remaining part of dynamics topics. Later we will solve some more problems, and in any common queries we will try to discuss here. And please send if you have any doubts. Once again, Google Forms we will clarify those doubts. Once again, best of luck today, and nice Tuesday for the remaining part of time. Thank you very much.